Hello everyone, in this video I explain capacitor. What is the capacitor? The capacitor is a device that can store and release the electrical energy. The capacitor has a symbol in the circuit. So the symbol of the capacitor in the circuit, it's like the cell, but the cell has one small and one big line, but in capacitors the two lines have the same length. So this is the symbol of capacitor. How can that capacitor store energy? That are the two plates connected to circuit. What happens when the switch is on? When the switch is on, the electrons move around the circuit from the negative to the positive. So that are the direction of it. Now, on that plate, we have more electrons coming from the cell. That electrons will repel to the electron in the other plate. So the electron in the other plate will leave that plate to the positive pole of the cell, leaving the positive charge. Then that plate contains positive charge. So the first plate contains negative charge, and the second plate of capacitor contains positive charge. So we have potential difference. This process will continue, and then it will be stopped when the potential difference of the cell equals the potential difference between the plates. In this case, we say the capacitor is fully charged. So charging the capacitor like this. So this is the voltage, and this is the time. So it increases gradually from 0 to maximum. The maximum value is the electromotive force of the cell. It is the electromotive force. So the voltage increases in the capacitor from 0 to the maximum. The maximum is electromotive force. It's like exponential curve. So this is charging the capacitor. What will happen when we discharge the capacitor? When we discharge the capacitor for the voltage and the time, look, this is the voltage and the time, this is the electromotive force, the voltage decreases gradually in exponential form. Does not touch. Okay? So this is the discharge of capacitor. The graph of voltage time. What about the graph of current time? It is the same. Also, the graph of current time. So this is the current, and this is the time. It is the same. The graph, it is the same. Okay? So also the charge time, it is the same. So we have four important graphs, Q and T. So this is the graph, starting from maximum to this one. So that three graphs for discharge capacitor, and the first graph for charge the capacitor. What about the capacitance of capacitor? The capacitance of capacitor noted by C equals the Q over V. Q is the charge in coulomb, V is the voltage in volt, and C is the capacitance in farad. The unit of capacitance is farad. So 1 farad equals 1 coulomb per volt. Farad is a big unit, so we use microfarad. What is the relation? Okay, 1 microfarad equals 10 to the power negative 6 farad. We have three factors affecting the capacitance of capacitor: the area of the plate, the distance, the insulated material between the plates. The capacitance of capacitors increases as area of the plates increases, direct proportion. The capacitance increases as the distance decreases, inverse proportion. Also, the capacitance depends on the dielectric. So, C equals EA over D. So, that are the factors affecting the capacitance of capacitor. Let us we see the next part of capacitor, the energy in capacitor. When we represent the relation between charge and V, we know that Q equals C. C is constant. The capacitance of capacitor is constant. So Q proportional directly to V. So when we represent the relation between Q and V, we will get a straight line passed through the origin. So this is Q and this is V. So the relation between Q and V in the capacitor is a straight line passed through the origin. The area under this graph represents the work done, the energy stored in the capacitor. So the area under this graph, the area under this graph, so the area represents the work done, represents the energy stored in the capacitor. What is the area of this triangle? It is a triangle now. It's half base times height. So the energy of capacitor, it's half V times Q. Take care, if you have this graph, you have to take the maximum charge with the maximum voltage. The energy in capacitor equals half QV. Take care, we studied the energy before. The energy generally is QV, Q times V. But in case of capacitor, the energy is half QV. Don't use this formula in any other device, just in capacitor. In capacitor, the energy is half QV. But if we don't have Q and we have CV, so we can say also the energy, when replace Q by CV, CV times V, it is CV squared. So the energy in capacitor measured in Joule equals half QV or half CV squared. So we have this formula, the energy equals half QV or the energy half CV squared, depends on the given. And the energy measured in Joule. Let us we see this topic, combined capacitance. We can connect the capacitors in parallel or in series or mix. Capacitors in parallel, this is the way. Capacitors in series, this is the way. What is the difference? In case of capacitors in parallel, we have the same voltage. So, same voltage. So, in parallel, it is the same voltage. What about in series? The current in series is the same. So, we have here the same current. So, the current is the same. At the same moment, the current and the charge is the same. So, it means the same charge. Because it is the same current and Q equals IT, so at the same moment, the current and charge the same. So, in case of capacitors in series, the charge is the same. So, the same charge. So, here we have the same charge. In case of parallel, the same voltage. In case of series, the same charge. But in case of voltage, different charges. So, the same here. In case of parallel, different charges. So, because it is different charges, we can say Q total equals Q1 plus Q2 plus Q3. Because different charges. So, we can say Q total equals Q1 plus Q2 plus Q3. What is Q? It is C times V. So, Q total is C total times V total. Q1, it is C1 times V. Because V total is the same. So we don't need to write V total, just V. So Q1 it is C1 times V, Q2 it is C2 times V, Q3 it is C3 times V. We cancel V with V with V to get this formula in case of parallel. C total equals C1 plus C2 plus C3. So In parallel, we have this node, it is the same voltage, and C total, the equivalent to capacitance, is the sum, C1 plus C2 plus C3. Now, in case of same charge, in case of series, we have different voltage. So, different voltage, so we can say V total equals V1 plus V2 plus V3. What about V equals Q over C? So, V total is Q over C total. We don't say Q total because it is the same charge. So V1 it's Q over C1. V2 it's Q over C2. V3 it's Q over C3. We can cancel Q with Q, but we have to put 1 because it's a fraction. So when we divide by Q, so we will get this formula in case of series. So 1 over C total equals 1 over C1 plus 1 over C2 plus 1 over C3. We can take a special case. If we have two capacitors in series, so capacitors in series, so we can say C total equals C1 times C2 over C1 plus C2. This is a special case if we have just two capacitors in series. Let us see this question in page 130, question number 13, in Future in Physics, the new edition. He said, the diagram below shows a graph of voltage V against the charge Q for two capacitors. First, you have to read the graph. This is a voltage in volt, so this is 3 volts and so on. This is the charge, but it is in microcoulomb. So take it, we have to multiply by 10 power negative 6 down. And we have two capacitors, C1 and C2. He said define the capacitance. It's okay, we can define this easily, but we solve the second part. If the capacitors were connected as shown in the circuit below, calculate their equivalent capacitance. So we need C total of this circuit. First of all, we have to get C1 and C2. We know that Q equals Cp and Q proportional to V. So if we draw Q on y-axis and the V on x-axis, the graph is a straight line. The slope of that line represents the capacitance. The slope or the gradient, so the slope equals the capacitance. But what happened? We represented the voltage on y-axis and the charge on x-axis. If we represented the voltage on y-axis and the charge on x-axis, the graph also will be a straight line. But in this case, the slope equals 1 over C. So the capacitance in this case, the capacitance not equals the slope direct. No, the capacitance C equals 1 over the slope. In this case, this is the voltage and this is the charge. So we find the slope of each and reverse and converted it, okay? Flip it. The first case, C1, what is the slope of this line? The slope is vertical change over horizontal change. So we can take this triangle to get the slope. This vertical change over horizontal change. The vertical change is 3. Over the horizontal change it's 18. From 0 to 18, so it's 18. But take care, it is not 18. It's 18 microcoulomb. We have to change it to coulomb. So multiply by 10 to the power negative. This is the slope. So C1 here equals 1 over the slope. So we flip it. So it is 18 multiply 10 power negative 6 over 3. 18 divided by 3 equals 6. So it is 6 multiply 10 to the power negative 6 farad. The capacitance in farad. If the charge in coulomb and the voltage in volt is the capacitance in farad. Also in the second line, C2, we find the slope. The slope is vertical change over horizontal change. So it will be 3 over 12 multiply 10 to the power negative 6. The same. So we flip this. So C2 equals 1 over the slope. So we flip this, so it will be 12 multiply 10 power negative 6 over 3. 12 divided by 3, 4. So the answer is 4 multiply 10 to the power negative 6 farad. Now we have C1 and C2. So what about this connection? He said find the equivalent capacitance. So we need C total. Which connection this one? It is series connection. And they are two. So in case of series connection, series capacitors, in case of two, so we can say C total now, the equivalent capacitance, equals C1 multiply C2 over C1 plus C2 because they are series connection. C1 equals 6 because all in farad we can say it is 6 microfarad and 4 microfarad. But it's better to write them in the same. So this is 6 microfarad. It's better to simplify. Because it's 10 power negative, you can say 6 microfarad. And this one, it's 4 microfarad. To get easy calculation. So C1 multiplied by C2, it is 6 multiplied by 4 over C1 plus C2. So it is 6 plus 4. 6 multiplied by 4, it's a 24. 6 plus 4 equals 10. So it's a 2.4 microfarad. This is C total. So C total equals 2.4 microfarad or 2.4 multiplied 10 power negative 6 farad. So this is the answer. Let us we see this question from past paper. He said consider the circuit and answer the questions which follows. This is the circuit. How many capacitors we have in that circuit? 1, 2, 3, 4, 5, 6, 7. We have 7 capacitors. The first part of the question, what is meant by saying that the capacity is equal to 8 microfarad? What do you mean by that? The ratio between the charge on the capacitor to the potential difference across its plate is equal to 8 microfarad. Now, the second part of this, the second part is that calculate the equivalent capacitance between A and B. We need to get the total capacitance. That 3 capacitors are in parallel. So we add them up because in parallel we add. So 6 plus 10 plus 8. So we can replace that 3 capacitors but by just one capacitor, 24 microfarad. From where this one, just we add them up. 8 plus 6, 14 plus 10, 24. And then we have here this capacitor. We simplify the circuit. Also, these 2 capacitors are in parallel. We add them up. 8 plus 4, it's 12. So, we replace these 2 ones by just one capacitor. Then we simplify the circuit in this way. So, this is 24 and this is still 8 microfarad. The 2 ones, 8 plus 4, it's 12 microfarad. And this one, 6 microfarad. Simplify more. The 2 capacitors are in series, so we use this formula. So we can get C total of this one. So C total equals the C1 times the C2 over C1 plus C2. So it is 24 multiplied by 8. Why we use this? Because they are 2 capacitors in series. Over 24 plus 8. We use the calculator to get this answer. So the answer here, it is 6 microfarad. This one also is the same. So C total 2 equals C1 times C2 over C1 plus C2. So it is 6 multiplied by 12 over 6 plus 12. It's 4 microfarad. We replace this circuit by just one here and this one. So this is the point A and this is the point B. This is the C total 1, which is 6 microfarad, and this is C total 2, which is 4 microfarad. They are parallel, so we add them. So C total, the answer is 6 plus 4 equals 10 microfarad. So C total equals 10 multiplied 10 to the power negative 6 farad. So this is the answer. The answer of this part, C total equals 10 microfarad or 10 multiplied 10 power negative 6 farad. The third part, we need the potential difference across 10 microfarad capacitor. If it has a charge, so the charge on this capacitor is 1 multiplied 10 power negative 4 coulomb. What is the required in this one? We need the potential difference across this one. So we need the potential difference across this one. How to get the potential difference across this one? The potential difference is V. So which formula is it? V equals Q over C. Equals Q over C. What is Q? Q is given. It is 1 multiply 10 to the power negative 4. What is C? This is the capacitance, but it is in microfarad. We change it to farad, multiply 10 power negative 6. So over 10 multiplied by 10 to the power negative 6. So we can get the answer of this one. So the answer will be 10 volt. Let us, we see this question from past paper about the capacitor. The following table shows the values of charge Q and the potential difference V across the plates of a capacitor until it charged completely. So this is the charge Q, but take care, it's in microcoulomb, and this is the voltage in volt. Part 1, calculate the total work done. Calculate the total work needed to charge the capacitor completely. So we need the energy. So the energy equals what here? We have Q and V. So which formula is it? Half QV. So the energy, it's a half QV. But which Q and which V? The maximum Q and the maximum V. So don't choose any Q and any V. No, we take the maximum charge and the maximum voltage, because he said that calculate the total work needed to charge the capacitor completely. To charge the capacitor completely, we need the maximum charge with the maximum voltage. So we use the charge as 40 microcoulomb and the voltage is 15. But take care, we have to multiply by 10 to the power negative 6 because it's in microcoulomb. So the answer is half multiplied by Q, which is 40, multiply 10 power negative 6, multiply the corresponding voltage is 15. So we can calculate this value. So when we calculate this, the answer will be 3 multiply 10 to the power negative 4 joule. So this is the answer of the first part. The second part of this question, he said what here? What happens to the energy stored in the capacitor when the potential difference V is increased to 18 volt? What happened? Nothing. Because it's already charged completely. So nothing. It will be the same. So what happened to the energy stored? It will be the same. We can't increase the energy because already we take the maximum charge. So this is the maximum energy stored. So it will be the same because the capacitor already charged it completely. I hope you understand this. Thank you very much.